Hello and welcome to Chapter 7 of our Network Essentials 2 course, Virtualization and Cloud Computing. The question that we will be answering today is related to the topic of virtualization and cloud. The learning objectives for today are as follows. Number 1, understand the virtual machines and the virtualized network infrastructure. Number 2, describe cloud computing categories and models. Number 3, understand how encryption protocols help secure networks. So let's move to virtualization as our first topic for today. The definition of virtualization as given by NIST. NIST is the standard that we are going to use for most of the definitions that we are going to use today. It is defined, virtualization is defined as the simulation of the software and or hardware upon which other software runs. A methodology for emulation or abstraction of hardware resources that enables complete execution stacks, including software applications, to run on it. Some of the key definitions that I would like for you to understand related to virtualization are as follows. Host, the physical computer hosting a virtual machine. So it's the actual hardware computer that will be hosting one or more virtual machines. Number 2, guest, a virtual machine that runs an instance of an operating system or OS and its applications. You can customize the type of operating system, the memory, the hard disk, and the processor on the VM or guest system. Hypervisor, the virtualization component that manages the guest operating system on a host and controls the flow of instructions between the guest operating system and the physical hardware. So this is an excellent graphic of hypervisors, and there are two. We are going to talk about type 1 hypervisor on the left and type 2 hypervisors on the right. So let's talk about the one on the left, the type 1 hypervisor. That is a type of hypervisor that is installed on the physical server, on the hardware. So picture yourself having a powerful server hardware in front of you, which is depicted by this picture right here. So imagine this is the server hardware that was given to you, and you want to use that server hardware to create virtual machines on it. In order to do that, you will need to install a type 1 hypervisor software. And examples of type 1 hypervisor software is given by VMware ESXi. That is a very well-known hypervisor type 1 that is used by a lot of companies and organizations to manage their virtualized environment. So you install this software by the name of VMware ESXi on the physical server or the hardware that was given to you, and then you can deploy virtual machines on top of the type 1 hypervisor. So there is nothing between the type 1 hypervisor and the physical server. You are installing VMware ESXi on the physical hardware, and then on top of the VMware ESXi, you install virtual machines. The same applies with Microsoft Hyper-V, which is the competitor of VMware ESXi. You can also install Microsoft Hyper-V on the physical server or hardware, and then install virtual machines on top of Microsoft Hyper-V. Another option is Oracle Hypervisor and VMware vSphere. For type 2 hypervisors, we have a different setup. So in this case, you have a physical hardware. It could be a very powerful desktop computer, not a server. It could be a desktop computer, for example, or it could be a laptop that has enough memory and a good processor. You can use that as the physical hardware for a type 2 hypervisor. Again, a powerful desktop computer or a laptop with enough memory and CPU. What you do in that case is you install any operating system that you want on your laptop or on your desktop computer. It could be Windows 10, for example, or it could be Mac OS, or it could be a version of Linux desktop running on that particular physical desktop or laptop. And then on top of that operating system, let's say Windows 10, to use as an example, you will be installing the software that is the type 2 hypervisor in the form of Oracle VirtualBox, being one of the examples, VMware Player being another example, or Microsoft Hyper-V Desktop Edition that will be installed as the type 2 hypervisor. So you install the type 2 hypervisor software that I am pointing at right here on top of the operating system that is running on your desktop computer or on your laptop. That is the typical setup that I have shown in other videos that I have ran. I use on my computer what is called the Oracle VirtualBox as the type 2 hypervisor of my preference. And what I do is I create virtual machines on that particular type 2 hypervisor, and then I use that as a software that is running on top of my Windows 10 computer or operating system. So that is the difference between type 1 and type 2 hypervisor. This layer right here is the difference pretty much. So with the type 1 hypervisor, you are installing the type 1 hypervisor software directly on the physical hardware that is given to you in the form of a server. And with the type 2 hypervisor, what you're doing is you're installing the type 2 hypervisor software on top of the operating system that is running on the hardware that was given to you. It could be a desktop computer or a laptop, for example. Now we are going to talk a little bit about the Virtual Network Interface Card, or VNIC. Every VM that you install can have one or more VNICs. VNICs connect VM and host. Connection is called bridge or switch, and a host can support multiple virtual switches. Each computer user has a Windows local account that works only on a single computer. So for the different networking modes that are available with the VNICs, we have bridge, which is depicted in this picture right here on top. In the bridge network mode, what we have is the VNIC accessing the physical network using the host machine's NIC, or network interface card. It has its own IP address, gateway, and netmask from DHCP server on the physical LAN. So let us take a look at this particular picture for the bridge mode, the one on the top section of this left pane that we are pointing at with a laser. So we have a VM number 1, we have VM number 2, so two different virtual machines. And the networking mode that we assign is the bridge mode. In this case, the VNIC, or the virtual NIC, for each of these virtual machines is getting the IP address from a DHCP server that resides on the physical network. So if this is the host, which is this box right here, The host is connected to the physical switch, and the physical switch, which is the one that I am pointing right here, is connected to a DHCP server on your network. And that DHCP server is the one that is giving or assigning the IP address to the virtual machine that is running on your host. And that is thanks to the type of networking mode that you set up for your virtualized environment. In this case, we are assuming that you selected the bridge mode as the mode for this particular setup that I am pointing at right here. So the next one is the NAT setup for the NAT mode for the second networking mode that we are going to talk about, and that is depicted in the diagram or the picture right here on the left side, the one that I am pointing at with my laser. In the event that you set up your networking mode as NAT, the VNIC, the virtual NIC on the virtual machine, relies on the host machine to act as the NAT service or device. And that the host is the one providing the IP address and all the details associated with the IP address and acting as the DHCP server for the virtual machine. So let's take a look at this picture right here, and this is the one that is set up as the NAT mode for networking for this virtualized environment, the one that I am pointing at right here. We have the host. This is the host. There are two VMs, again, two virtual machines. However, the IP address that is assigned to each of these virtual NICs on these VMs, these two VMs, is coming from the DHCP service that is running on the host. So the DHCP on the host is the one that is giving the IP address to the virtual machines, to the VNICs on the virtual machines. The last networking mode that we are going to talk about is the host only. The host only mode is one in which the virtual machines on one host can exchange data with each other between virtual machines and the host, and cannot communicate with nodes beyond the host. So let's take a look at this last picture that I am pointing at with my laser, that is depicting the host-only mode setup for the networking in this virtualized environment. So the host is right here, and there are again two VMs, two virtual machines, VM number 1 and VM number 2. In this case, these VMs are able to communicate with each other only and with the host, but they cannot communicate with other systems on the physical network. There may be other computers right here on the physical network, but these two VMs cannot communicate with them. So now we are going to talk about the advantages and disadvantages of virtualization. For the advantages, we have the efficient use of resources, the cost and energy savings that come with the advantages of virtualization. You're actually using one single piece of hardware and giving or assigning different VMs that are hosted on this single piece of hardware. So you're saving energy. You're not connecting 20 computers. You have only one, and then 20 virtual machines running on this single hardware. And then you have fault and threat isolation and simple backups, recovery and replication. Those are the advantages of virtualization. So now for the disadvantages, we have the compromised performance, because now we are talking about several computers or virtual machines running on a single piece of hardware. Then we have the increased complexity. You require some skills to be able to create a virtualized environment. Increased licensing cost. You need to pay for the licensing associated with a hypervisor, either type 1 or type 2 that you're running. And the single point of failure. So if this hardware dies, all the virtual machines that are hosted on this hardware will be gone unless you have the appropriate backup set up in place. But if this hardware dies, then 20 systems, assuming that you have 20 virtual machines running on this host, will be down. So that is why it is called a single point of failure. Now, for the network functions virtualization, or NFV, you have virtualized network devices. What does that mean? The following network devices can be installed on virtual machines. You have the ability not only to create virtual machines that are running, for example, Windows 10 or Linux or Apple Mac OS as computers, virtual computers running on a host. You can also virtualize not only computers, you can virtualize network devices. And examples of those network devices include a virtual firewall and a virtual router. So you can virtualize a physical router and make it a VM on a virtualized environment, and that will be a way of saving money. Now, the advantages of virtualizing network devices include the easier deployment and migration. You can quickly deploy a virtual router and migrate it to any other part of your network because it is software that is running on a host. It creates efficiency and scalability as well. Now, it is important to remember that these advantages come at a price. You will be paying separate licensing because those are required to deploy virtual network devices, and virtualized network devices can potentially increase your latency on your network. Cloud computing. So now we are moving away from the virtualization concept and now moving to the expansion of virtualization now in the cloud. So cloud computing is the flexible provision of data storage, applications, and services to multiple clients over a network. The characteristics of cloud computing include on-demand service, support for multiple platforms. You can pretty much deploy Windows, Mac OS, Linux, any type of network devices that are virtualized. You have the ability of resource pooling and consolidation. Meter services, meaning you pay for what you consume in the cloud. So if you have a virtual machine running in the cloud, for example, and you're using the Microsoft Azure cloud environment, you will only pay for the time that you're using that particular Microsoft Windows device in the cloud. If it is 4 hours, you only pay for 4 hours, because after the 4th hour, you shut down the device and you don't use it anymore. So you're only paying for the time that you are using the system. Elastic services and storage, meaning it is scalable. You can increase the resources, by that I mean memory, CPU, storage quantity for your servers running in the cloud whenever it is needed. And that allows you to pay only for additional storage when it is needed. And if you don't need the additional storage anymore, you can remove it, and thus saving money because you will not be paying for the same amount of storage anymore. Now, it can provide virtual desktops as well. The cloud computing environment has the ability to deploy virtual desktops. So operating environments hosted virtually can be created. And the developers, software developers, can load any kind of software on the servers that are residing in the cloud environment, and they can use that particular software for testing without compromising any type of hardware devices on site that the software developers are using. Now, most cloud services providers use virtualization software to supply multiple platforms to multiple users. Now, there are 4 different cloud computing categories. The first one is the traditional one. All hardware, software, and everything else is located and managed at the organization's location or data center. This is the traditional setup. The second one is the infrastructure as a service, IaaS. It is the hardware services and network infrastructure devices that are provided virtually, including end-user interfaces such as HVDs or hosted virtual desktops. So in this particular computing category for the cloud, you're getting the hardware and the network infrastructure devices provided to you by the cloud service provider. The platform as a service has the OS, the operating system, the runtime libraries or modules, the operating system provided to applications, and the hardware on which the operating system runs. And the software as a service is giving you not only everything that the platform as a service is giving you, but in addition to that, it is also giving you the applications, the software applications that are needed to run any particular software in the cloud. So infrastructure as a service is just the hardware and the network devices. Platform as a service includes the operating system and the runtime libraries on top of the hardware and the network devices. And the software as a service includes everything that the platform as a service is giving you, plus the application that your company will be using. Deployment models. There are 4. We are going to talk about the public cloud, service provided over public transmission lines, and this is pretty much what you see a lot of companies using in the form of Amazon Web Services, Microsoft Azure, Google Cloud. They typically go with the public cloud solution, meaning it is in a data center environment in the cloud that is available to the general public and shared by different companies. The next one is a private cloud. Now, this is a little bit more secluded, more secure as well. It is dedicated to an organization, so the service established on an organization's own servers in its own data center. And then we have the community cloud. It is the service shared between multiple organizations in a community. And finally, the hybrid cloud, which is a combination of any of the other service models into a single deployment. So you may have a mix of public and private. Many companies do that. They have what is called a sector of their computing environment that is public because they can host it in the public cloud. They don't have any high security needs or requirements for those applications that are running in the public cloud. But then they have another set of applications that are highly secure, and they choose to go with a private cloud model because of the security enhancements that are given by a private cloud setup. So in that case, in the case of a company that is using both public and private, they are in reality using a hybrid model, hybrid cloud model. Now, cloud computing security. There are some concerns about security in the cloud environment, and those concerns include the following. The internet service provider's uptime. You are relying on the internet service provider uptime to make sure that you're able to access your cloud environment. So availability is given to you or dependent on the ISP. The ISP impose bandwidth limitations. So there may be a bandwidth limitation that prevents you from transferring dramatic amounts of data between the cloud environment and your company because of those limitations. Now, the cloud provider's uptime, you're relying on either Microsoft, Amazon, or Google to make sure that their data centers are up and running whenever your company needs them. And if they are down, if those data centers are down, then your company will be down as well. Cloud providers' backup and security systems. You're relying on those cloud providers to have security and redundancy in place so your data is not lost and is always available to you. So you're relying on them. Misconfiguration that exposes one client's data to another client. So it could be that your applications could be running in a data center that is housed or hosted by Amazon Web Services, for example. And if the configuration of that environment is such that your company data is mixed with some other company's data, then the exposure for your client data is high. Unauthorized access to data by cloud provider employees or illegitimate users. So in those cases, you're relying on the safety and security steps that the cloud provider should be taking to make sure that they know who is working for them, and they run the background checks for those employees that have access to your data and to your servers in the cloud. Breaches of confidentiality, data security regulations, and questions over ownership of intellectual property stored in the cloud. Potential risks and limitations also include the risks to the network proprietary data or customer information caused by the bring your own cloud services on users' personal devices. Reduced consumer confidence, fines, lawsuits, and possibly criminal charges when cloud breaches occur. And this is something that has happened in the past. There are many companies that are running their infrastructure, their computing system in the cloud, and there have been instances in which their environment has been breached. Now, in that case, they need to make sure that they understand the jurisdiction of the data center in which the data is stored, so they are able to, number one, notify the appropriate authorities about the data breach, and they need to comply with any data or breach reporting requirements that may be present in that particular jurisdiction. There are data centers not only in the US but also in Europe, and if by any chance the company that you end up working for has data stored in one of the data centers in Europe, then they are subject to any laws as far as privacy and security that are existing or in existence in Europe rather than in the US, because the data center is under the jurisdiction of Europe. Ways to reduce risks of cloud computing include the use of encryption and carefully choosing the method by which your network connects to your cloud resources. So now we are going to talk about the last subject for today, and that is encryption. We are saying that encryption could be an excellent step to increase the security of any cloud deployment, and thus any virtualized environment. And the definition of encryption is the use of mathematical code called a cipher to scramble data into a format that can be read only by reversing the cipher. It is used to keep information private, primarily evaluated by three benchmarks: confidentiality, integrity, and availability. What is a key encryption? You have three different kinds. One is the private key encryption, public key encryption, and there is another element in key encryption that is called the public key server. So as far as the private key encryption, the data is encrypted using a single key, known only by the sender and the receiver. It is called asymmetric encryption whenever you're using just a private key only, because the same key is used during both encryption and decryption. Now, when you're using public key encryption, which is a different type of encryption, the data is encrypting using two keys rather than one. There is a private key and there is a public key. The private key is the one that is known only by the user, the one that has the data. And the public key is known by anyone that may request access to the data that the private user has. The final element of the key encryption concept is the public key server, in which we are talking about the server that has the publicly accessible host and freely provides users public keys. So it is kind of a server that is able to generate public keys for different entities, companies that are trying to create a public key encryption setup for the security within your organization. The key pair is the combination of public and private keys. This type of public key encryption is also called asymmetric encryption. Why? Because it requires two different keys. And let me stop right there because I want to highlight two important connections. The first one, whenever you're talking about private key encryption, you are also referring to symmetric encryption. Why? Because you're using a single key for both encryption and decryption. That's number one. Number two, the second connection that I want to highlight to your attention is the one between public key encryption and asymmetric encryption. Public key encryption relies on two keys, private and public. And that is the definition of the asymmetric encryption, requiring two different keys. Digital certificate is the one that holds the identification information and the user's public key. CA is the certificate authority. It is the one issuing and maintaining the digital certificates. And by maintaining, it also includes the expiration date for the digital certificate, which is something that you may have seen on websites. For example, whenever you're accessing a website, many of those secure websites have digital certificates, and in many cases they expire. So the owner of the website needs to make sure that whenever the expiration date is approaching, that a new digital certificate is installed, so there is no issues as far as the validation of the digital certificate when users are trying to access their website. Finally, the PKI, public key infrastructure, is the use of certificate authorities to associate public keys with certain users. Ipsec, or Internet Protocol Security, is defined as the encryption protocol suite that defines rules for encryption, authentication, and key management for TCP/IP transmissions. So that is what the IPsec is all about. IPsec creates secure connections in 5 steps: IPsec initiation, key management, security negotiations, data transfer, and termination. Those are the 5 steps used by IPsec. It operates in 2 modes: transport and tunnel mode. We will move away from IPsec for a second and talk about SSL and TLS. What is SSL? SSL is the Secure Sockets Layer protocol, and TLS is the Transport Layer Security Protocol. Both are methods of encrypting TCP/IP transmissions, including web pages and data entered into web forms. Both protocols work side by side and are widely known as SSL-TLS or TLS-SSL. Why is that so important? Because many organizations fail to upgrade to the latest and most secure version of SSL and TLS. And if you're running an older version of SSL and TLS, your environment, in many cases your entire network environment, is vulnerable to data breaches because the older version of the protocols that you are using in your company are subject to different security holes that can be exploited by hackers or cybersecurity criminals. When a client and server establish an SSL-TLS connection, they establish a unique session. The association between client and server defined by agreement, specific set of encryption techniques. It is also created by Ssl Handshake Protocol. The Handshake Protocol allows clients and server to authenticate with each other. It is similar to a TCP three-way handshake. So now you're seeing the reference between the security that is given by SSL and TLS. DTLS is the Datagram Transport Layer Security, and it is a variant of TLS designed for streaming communications. In summary, today we have covered the following. Virtualization is a virtual or logical version of something rather than the actual or physical version. Number 2, virtual machines or VMs can go through a virtual switch on the host computer to reach the physical network and can communicate with physical or virtual routers, other network devices, and other hosts on the local or another network. NFV is defined as Network Functions Virtualization and provides the ability of virtualizing network equipment. It provides flexibility, cost-saving options for many types of network devices. Number 4, cloud computing covers a broad range of services from hosting websites and database servers to providing virtual servers for collaboration or software development. Number 5, cloud computing service models are categorized by the type of services they provide. Cloud services are delivering a variety of deployment models depending on who manages the cloud and who has access to it. Number 7, one way to reduce the inherent risk of cloud computing is to use encryption. And we talk about encryption. The most popular kind of encryption encodes the original data bits using a key or a random string of characters to scramble the data and generate a unique and consistently sized data block called ciphertext. Ipsec, or the Internet Protocol Security, is an encryption protocol suite that defines a set of rules for encryption, authentication, and key management for TCP/IP transmissions. You will see Ipsec typically used for VPN connections. SSL, or Secure Sockets Layer, and TLS, Transport Layer Security, are both methods of encrypting TCP/IP transmissions en route between the client and the server using the public key encryption technology. Very important for you to remember. Number 11, SSH, Secure Shell, is a collection of protocols that does both authentication and encryption. And finally, RDP, or Remote Desktop Protocol, is a Microsoft proprietary protocol used by Windows, Remote Desktop, and Remote Assistance client-server utilities to connect to and control a remote computer. So this concludes the presentation for today on cloud and virtualization technology. Thank you very much. Until next time.